Today we will study the factors that affect the formation of electrovalent bond. Or the conditions for the formation of electrovalent bond, or the factors which affect the formation of electrovalent bond. Number first, we will take the valence electrons. Students, electrovalent bond is formed by loss and gain. Electrovalent bond is formed by loss and gain of electrons. By loss and gain of electrons. So the atom that loses electron is surplus of those electrons than the inert gas. Surplus of electrons than the inert gas. And it loses those electrons. That means it has 1, 2 or 3 electrons in the valence shell. For example, if we take alkali metals, sodium, potassium, they have 1 electron in the valence shell. Similarly, if you take alkaline earth metal, they have 2 electrons in the valence shell. And similarly, if we take boron, and after boron we take aluminum family. In aluminum it has 3 electrons in the valence shell. So these 1, 2 or 3 electrons which are present in their valence shell, in alkali metal 1 electron is present, so they attain the nearest inert gas configuration by loss of electrons. Similarly, alkaline earth metals attain the electron in this inert gas configuration by loss of 2 electrons. Aluminum attains electron in this inert gas configuration by loss of 3 electrons. So second element which gains the electron is deficient of those electrons. The atom that gains electron, the atom that gains the electron is deficient of those electrons, and it gains those electrons to attain the nearest inert gas configuration. For example, if you take the chlorine, it has 17 electrons total. 1 electron is less than the nearest inert gas configuration to form the argon. So it has these atoms which are deficient. These are deficient of 5, 6 or 7 electrons. That's 15, 16, 17 group elements. They have the tendency to gain the electrons to form this electrovalent bond. Now the we can say transient metals. If we take case of transient metals, they will also, and they have the tendency to they lose the electrons, but they do not attain the inert gas configuration. So the first factor is the number of valence electrons. Valence electrons, the atom that lose electrons has 1, 2 or 3 electrons in the valence shell, and those which gain the electrons have 5, 6 or 7 electrons in the valence shell. So they gain the atoms that lose electrons are metals, and the atoms those gain electrons are non-metals. That means this electrovalent bond is formed between the metal and the non-metal. Second factor, which is that is difference of electronegativity. Students, this is electrovalent bond is formed between metal and a non-metal. Bond is formed between metal and a non-metal. So metals are electropositive. Metals like alkali metals, which form are electropositive, and non-metals, they are electronegative. That means the atom that loses electron Those electrons are gained by the non-metal, which has the tendency to gain that electron. For example, if we take the sodium electropositive, they have the low value of electronegativity value. For example, it is zero point 0.9. In sodium, it is zero point 0.9. For example, if we take the 17 group element, first element, that is fluorine, it is electronegativity is 4. So the difference in electronegativity in case of sodium and fluorine is 3.1. That means this is high difference in the electronegativity. So electronegativity difference must be high between the condition is that those atoms which form the electrovalent bond, they must have high difference in the electronegativity. A difference of 2 is essential. That means if they have 2.1, 2.3, they will easily form the electrovalent bond. If it is less than 2, then they will not form the electrovalent bond, that they will go to another type of bond. Now in case of sodium, 0.9, and fluorine it is 4, so difference is 3.1. That means it is very high difference. So easily is the electrovalent bond formed between sodium and fluorine to form the sodium fluoride. Now third condition, which is energy concentrations. That means there must be overall decrease in energy. There must occur overall decrease in energy. Decrease in energy must take place. For example, what type of energy are involved in the electrovalent bond? We will see. First is the ionization enthalpy. Ionization energy, or we call it ionization enthalpy. So, for example, atom we give atom we give energy to an atom, it loses electron to form a cation plus one electron. That means ionization energy is the energy required to remove the electron from the outermost shell. That means the valence electron, valence shell. The energy required to remove the electron from the outermost shell of the isolated gas atom. For example, if we take the sodium, if we apply energy, if we give energy, that is 495 kilojoules per mole energy, it forms sodium cation and gives the one electron. Similarly, if we take the magnesium, it requires 743 kilojoules of energy per mole, it gives magnesium dipositive. Similarly, aluminum, if we take, it requires 3158 kilojoules of energy per mole, it gives aluminum tripositive. Here what we conclude: lower the value of ionization energy in case of sodium, lower the value of ionization energy, जितना कम होगा ionization energy, easily is the cation formed, उतनी आसानी से cation बनता है, and easily is the bond formed. That means the atom which undergoes the formation of electrovalent bond, ionization energy of the atom, that means that atom which loses electron should be low. If it has high ionization energy, then it is difficult. For example, magnesium and aluminum. Magnesium has ionization energy of +2. So though the bivalent magnesium is formed, but we need 743 kilojoules of energy. Similarly, though aluminum tripositive is formed, but it needs very high ionization energy. That means low ionization energy is necessary for the formation of electrovalent bond, so the cation is formed easily. Though these bivalent highly charged species are formed, but they require high ionization energy, and difficulty occurs in the formation of ionization, this electrovalent bond. Second type of energy which is involved, that is called electron affinity. Now, for example, atom A, it loses electron, it forms A part cation +1, so हमें वो electron, that is called ionization energy. Now second, B atom, which accepts this electron, gives B negative ion. That means it gives energy. So electron affinity. We call it electron affinity also. We call it electron gain enthalpy also. Electron gain enthalpy. It is the energy released. It is here the energy in electron affinity, or we electron gain energy is released when an isolated gas atom accepts electron. For example, it is, if we take for example chlorine, we 348 kilojoules of energy per mole. If we supply this, it gives, if we give chlorine, it gives plus one. If we add an electron to chlorine, it will give chloride ion, and 348 kilojoules of energy are released. 1 mole of chlorine, if we add a 1 mole of 348 kilojoules per mole are released. That means this amount of energy is released when chlorine accepts the electron to form a chloride ion. For example, if we take oxygen, to add 1 electron, it gives O negative ion plus 142 kilojoules of energy. But if we take O negative, if we add another electron, then we have to add energy. Then delta this O di negative, then we have to give minus 6900. That means we have to supply the energy. What do we conclude? We conclude that higher the value of electron affinity, that means higher the energy is released, more the energy is released, more the energy is released. जितनी आपकी ज़्यादा एनर्जी रिलीज होगी, एनर्जी रिलीज हो रही है, easily is the cation formed, easily is the anion formed. anion form, जो anion जो आपका बनता है, easily is formed. For example क्लोरीन में आसानी से बनता है as compared to ऑक्सीजन बाइवेलेंट, क्योंकि हमें यहाँ से सेकंड इलेक्ट्रॉन ऐड करने में हमें यहाँ से एनर्जी देनी पड़ती है, नियर अबाउट 553 kilojoules of energy we have to give, because we are here, we have to count electronic repulsion also. So मोर एनर्जी रिलीज, जितनी आपकी एनर्जी ज़्यादा रिलीज होती है, उतने आसानी से आपका एनाइन बनता है, एंड easily is the bond formed. This was the second electron affinity. And third type of energy which comes into that is called Lattice energy. Now you have seen that in formation of one atom has lost electron, it has formed cation, and other atom has gained electron, it has formed anion. Now these oppositely charged ions come close together and they form the crystal. Now वहां पर आपकी एनर्जी रिलीज होती है, एनर्जी रिलीज्ड when requisite, जितनी requisite number of positive, requisite number of oppositely charged, that is cations and anions, charged ions combine to form 1 mole of ionic crystal. So उसको हम बोलते हैं, and this is Lattice energy. So जितनी Lattice energy आपकी ज़्यादा होगी, जितनी एनर्जी ज़्यादा निकलेगी, रिलीज हो जाएगी, उतने आपका easily more energy released, more the Lattice energy आपकी जितनी ज़्यादा है, एनर्जी जितनी ज़्यादा रिलीज हो जाएगी, easily is the compound form, उतनी आपका कंपाउंड इजीली बनता है. अगर लेस एनर्जी है तो वो स्टेबल नहीं होगा. मोर द एनर्जी रिलीज, मोर द लेट्स एनर्जी, दैट मीन्स स्टेबल इज द कंपाउंड, वो कंपाउंड आपका स्टेबल होगा, एंड मोर इजीली इज द फॉर्म्ड. इफ इट इज लेस एंड लेट्स एनर्जी, वो उतना स्टेबल नहीं होता है. सो दैट मीन्स आपकी एनर्जी जो आ गई, एक तो आपकी इलेक्ट्रॉन एफिनिटी आ गई जो आपकी एनर्जी रिलीज होती है, दूसरी आपका लेट्स एनर्जी जो आपकी रिलीज होगी, इट मस्ट बी ग्रेटर देन द इलेक्ट्रॉन this ionization energy. So electron affinity or Lattice energy जो है, it must be greater than the ionization energy, then the bond is formed. For Lattice energy you need more to, it depends upon size of ion and radius of ion. So these two factors, that means energy and electron affinity and the Lattice energy must be greater than the ionization energy, then the energy will be released, and then there will overall decrease in energy, and the stable ionic bond will form and the compound will be stable.